Okay, so this is page 42 in the packet, number 2, even though I didn't number them. Okay, let's see. My computer is not being very nice today. Okay, let's try this out. Okay, so what mass of BaCl2 is formed when 856.75 grams of BaOH2 is reacted with 218.76 grams of HCl? Okay, so the first thing I have to do is balance the equation. All right, so hopefully you can balance pretty easily by now. If not, then that's a skill you definitely need to practice. Okay, but I'm not going to do that here. So this is going to be a 2, 1, 1, 2. Okay, pretty simple. Okay, molar mass. Hopefully you know how to find this by now. You got to look on the periodic table for H and Cl. Okay, H is like 1.01 and Cl is like 35.45 or something. Okay, so this one comes out to be 36.46. And the units are always grams per mole for molar mass, because that's what it means. It's telling you that in this compound, in 1 mole of it, which means that big number of particles, there are 36.46 grams of it, okay? BaOH2 should be 171.34, okay? All right, make sure that you know there's 2 O's and 2 H's here, okay, and only 1 Ba when you add these up. Okay, this one should be 208.23 grams per mole, and water is about 18.02 grams per mole, okay? All right, so you're actually gonna need this step now, all right? Because the difference in this problem compared to the other ones is it's telling me the mass instead of the moles, all right? But to do all the other steps, I need to know how many moles, so I'm gonna go back and figure that out first, okay? So if I have barium hydroxide here, okay, and I have 856.75 grams. This is the starting amount, so I always start with that. The given thing always goes first, okay? Then I'm always going to multiply by the molar mass when I'm changing from grams to moles, all right? So you need to know that this is 171.34 grams in 1 mole, okay? So if I have grams on the top, I need grams on the bottom so that it cancels, okay? Because it's 171 grams in 1 mole, okay? Because then that's going to cancel. It's going to leave me with moles, all right? So that turns out to be 5 moles, okay? And I made these numbers really clean because we're going to do the graph, okay? All right. We also need to check the HCl because it tells me how many grams of HCl react, because I have to decide which one's going to be my limiting reactant. Okay, so for this one, same thing. The grams has to go on the bottom and 1 mole on the top so that I can cancel that and find out how many moles this is. Okay, so 218.76 divided by 36.46 is 6 moles. Okay. All right, so that's my starting. So the only thing different is in the problems prior to this, it just would have said 5 moles of this, and it would have said 6 moles of this. That's the only difference. You just have to do one more step, all right? Because like in a lab situation, right, like you're going to do later this week, you're going to have grams. You don't measure moles. You measure grams, and then you have to convert it, okay? All right, now I'm going to have a bunch of different equations. So I'm going to have HCl, the BaOH2, okay, the BaCl2 is my first product, and then water is my second product, okay? All right, so now I have to write the equations, which should be pretty easy. So the reactants are always going to be negative because they're using the reactants to turn into the product. So here I'm going to look at the coefficients. So I know every time the reaction progresses, I'm going to have -2 because I'm losing 2, plus 6 because that's what I started with from here, okay? My BaOH2, okay, I'm losing 1 every time, and I started with 5, okay? My barium chloride, I have 1 every time. I'm gaining because that's a product, and I always start with no product, okay? And my water, I'm gaining 2 every time, and I started with nothing, okay? All right, so once you write the equations, then you can go ahead and graph it, and I'm going to make my reaction progress across here by just skipping a space to spread it out a little bit. Okay, so remember, this is the reaction progress down here, all right, and this up here is the moles of whatever the substance is, okay? And I only need up to 6 moles this time, so unlike some of the other ones, I'm going to spread this out a little bit, okay, so that it's just not so scrunchy. It'd be easier to see, okay? All right, so let's graph first this one in orange. So for the HCl, I'm gonna start with 6, and then every time the reaction progresses, I'm gonna go over 1 here, and I'm gonna go down 2 to 4. So it's gonna go to here, I'm gonna go down 2 more, and the reaction goes another cycle, and then I'm gonna go 2 more, and the reaction goes another cycle. Okay, so here's gonna be my HCl line. Okay, the barium hydroxide, let's make that one purple. Okay, he's gonna start with 5, all right, and then every time the reaction goes, it's gonna go down by 1. So I'm gonna go down 3 over 1, down to 2 over 1, down to 1 over 1, down to 1 over 1. Okay, so here goes my, whoa, boy, that's bad. My BaOH2 line, or squiggle, as the case may be. Okay, all right, good. All right, now let's look at the products. Okay, let's see if yellow shows up. Okay, I'm gonna make the BaCl2 yellow. It's gonna start with nothing, and then every time the reaction goes, it's gonna go up by 1. The reaction goes up by 1, the reaction goes up by 1, the reaction goes up by 1, etc., etc., etc. Okay, so there's that one. All right, and then how about blue for water? Okay, water's going to gain 2 every time. So when this reaction goes, water actually gets 2 moles. It goes again, and I get up to 4. It goes again, and I get up to 6. It goes again, and then I run out of space. So I'll do this one here. Okay, all right, so here's my lines. All right, if you're not using colors, you need to make sure you label it somehow, okay, or else I'm not going to be able to tell what it is. Okay, all right. Now it's pretty easy to see who the limiting reactant is, all right, because as the reaction progresses this way, this is going to run out first, and that was the HCl. All right, so the limiting reactant is going to be HCl, and then the excess reactant is going to be this one, which is the BaOH2. Okay, all right, at reaction completion, all right, I have all of my things, and water. Okay, all I have to do is look, this is where the reaction stops because I've run out of HCl. So the reaction can't go any past this because I've run out of one of the reactants. So nothing else can happen. Okay, all right, so that means I'm going to have no moles of HCl. Okay, I'm going to follow this line up and look here. And the purple was the other reactant, BaOH2, and I can see that I'm going to be left with 2 moles of that when I'm done. Okay, the yellow one was the BaCl2, and I can see I'm going to get 3 moles of that made. Okay, and then the water's going to end up with 6 moles. Okay, so I'm going to use this to make sure that I am matching up when I do my Bca table and the dimensional analysis. Okay, all right, so let me pause this, and then I have to get another screenshot because it doesn't fit. So hold on. You pause it if you need to fix it. Okay, so here's the rest. Sorry, it has that little X in the middle because of the screenshot, but okay. All right, so now I'm going to do my Bca table. Okay, so in the given part of the problem, after I converted from mass, okay, hang on, let me get my pen back. Okay, after I converted from mass, okay, the HCl started with 6 moles of HCl, okay? The BaOH2 started with 5 moles, okay? And my products always start with nothing because they're products. Nothing's happened yet in the reaction, okay? Remember, the change is where I'm going to use my limiting reactant. This is what's driving the reaction, okay? So the HCl is the one that was completely used up. So 6 moles of HCl are used to leave me with nothing, okay? This is the thing that has to go in all of the spots, okay? And I'm not going to write moles because I can't fit it, okay? But that's what we're doing, okay? So all of these, right, are going to start with what was the limiting reactant because that's the thing that's driving the reaction. Then I have to figure out with the ratios, okay, what is, what's it going to make, okay? All right. So my HCl is on the top, so I always need HCl on the bottom, okay? So if I look at the coefficients, I can see that every time the reaction goes, I'm going to use 2 moles of the HCl. So that's going to go on the bottom. Okay. And then on the top, I'm going to put what is the thing that I need. And I'm going to look at the coefficients and see that the BaOH2 is a 1. Okay. The BaCl2 is a 1. BaCl2. Okay. And the water is a 2. All right. Okay. So then I'm just going to figure out what they are. So the HCl's are going to cancel. So -6 times a half is -3. Okay. If I started with 5 moles and I changed by -3, I'm going to be left with 2 moles of BaOH2. Okay, and when you look up here at your graph, you can see that that was the same thing. Can you stop whatever that is? Annoying. Okay, all right, so I start with no moles of BaCl2, and I had 6 times a half, so I've added 3. So that means I'm going to end up with 3 moles of the the BaCl2. That's this column. Okay. And for my water, 6 times the ratio 2/2 is just going to be 6. So that's how I see that I'm getting 6 moles of water. Okay. All right. And that should match what your graph says. If it doesn't match, that means you did not do it right. It has to match. All right. Now I'm going to go and I'm actually going to find the answer to the question, which they said, what mass of BaCl2 is formed, okay? So this is the guy that I care about, okay? I can do it for any of the other ones, but it doesn't ask it, so I'm not going to do it, okay? But you can really do it for any of them, okay? So I'm going to go with, I'm going to go with what I started with, okay, which I know there's 3 moles of BaCl2 created, okay? And I want to know how many grams that is. So I'm going to go back to my molar mass up at the top. And I can see that there's 208.23 grams in 1 mole. Okay. Right. And I need the moles to go on the bottom so that it cancels this one. All right. And that's going to end up giving me 624.7 grams of BaCl2. Okay. All right. And then technically that's the answer. So now the problem is finished. Okay. There's other ways to do it, right? You could have continued it from the graph. You can use the BCA, or we're going to use dimensional analysis, okay? Because when the numbers aren't so clean, you have to be able to do it probably without the graph, okay? Because it's just not as easy, all right? So when you're doing the dimensional analysis, the first thing you're going to do is test for the limiting reactant, okay? So I know I started with 6 moles of HCl, okay? And I also started with 5 moles of BaOH2. So the first thing I have to do is figure out who's the limiting reactant. Okay, that's the one that's going to run out first, so I need to see how much product it can make. Okay, so now I'm going to look at the ratios. All right, so when I look back up at my ratios, I know there's 2 moles of HCl makes 1 mole of the BaCl2. So I see that this is going to make 3 moles of BaCl2 if I use up all of this. Okay. Now, the other one, the BaOH2, if I look at my ratios, I have 1 mole of BaOH2, and that gives me 1 mole of BaCl2. That's from the ratios. Okay, so 5 times 1/1. This one could make 5 moles of the BaCl2. Okay. So that tells me that's not going to happen. That's too much. This guy has to be the limiting reactant. This one's the excess. All right. So once I know who my limiting reactant is, HCl, he's the limiting reactant. It's going to make 3 moles of BaCl2. Okay. I already saw this in the graph, but if you didn't have the graph, you would have to do this first because otherwise you don't know what to start with. Okay. Now you do the real dimensional analysis. You'll start with what's given, okay, which is this, or technically a step back, right? You could start with 218.76 grams of HCl, okay, and then you would turn it into moles, okay? That's the step that we did way up at the top when there was 36.46 grams of HCl in a mole. Okay, when I multiply these two things together, this is where I got 6. This came from this, okay, but we're just doing it all in one step, okay? All right, now I would try to find out how much of the thing that I want I can make, okay? So now I'm going to look at my ratio. So I'm going to have 2 moles of HCl, this is from my equation, is going to give me 1 mole of